We will proceed in primitive calculus, and we have seen numerical algebraic calculus. We will see vector. So, till now we have seen many aspects in calculus. So, calculus started with a discussion. Calculus started with a discussion on calculating the collection, that is the addition. But slowly we moved to algebra, and then we moved to we saw polar coordinate system also. So what is missing in our discussion is vector. So we have numerical signs that we have seen. So in numerical signs, if we need to do addition, then we can do addition. So in numerical signs, if we need to do addition, then we can do the addition. Then another form of the addition is multiplication, that also we saw. Then we saw that if we want to do calculation of addition and multiplication, then there is another form, that is called drawing the algebraic curve, drawing the graph, and in the graph calculate the area. So if you are able to calculate the area, okay, so if you are able to calculate the area, if you are able to calculate the area drawing the graph, then also we can calculate the correction, addition, that is integral calculus. So when we draw the graph, we need algebra. So algebra, and then calculating the area from algebra. If I have a always I say a person is walking 2 km per hour. So algebraic equation is 2 into x to the power 0, where x is independent component. Then we can draw a flat line and height is 2, whereas width is x. So at any moment, how much kilometer he has walked is 2 into x. If person is walking 2 km per hour, at the end of 5 km, how much he has walked? This is numerical multiplication, 2 into 5. A person is walking at the speed of 2 into x to the power 0, where x is independent component and there is a function over independent component called fx, where fx is equal to 2 into x to the power 0. Then the how much person has walked is nothing but multiplication, that is 2 into x to the power 0, or fx into x at any time x. This is algebraic multiplication. 2 into x to the power 0 fx into x. So 2 into x to the power 0 into x. So any moment how much kilometer he has walked is 2x kilometer. Okay. What about if this algebraic equation is not constant? 2 into x is the rate of collection, is the speed at which he is walking. So if he is walking at a speed of 2 into x, then at the end of x, or how much he has walked, fx into x. Fx is height into x. One is numerical, height is 2 and width is 5, then 10 kilometer he has walked. One is algebraic, where fx is 2 into x and width is x, then 2 into x square. Fx into x, that much he has walked, algebraic multiplication, but that is not true. Certainly he has not worked 2 into x square. Then numeric multiplication, algebraic multiplication, next comes as integral calculus. Integral calculus is saying that don't do multiplication, don't concentrate on addition and multiplication. If you really want addition or multiplication, then concentrate on calculating the area. If you calculate the area, then you can calculate the actual addition. So 2x, if this is x-axis, then 2x will be a slant line that will form a triangle. The area of triangle is nothing but area of rectangle, what it makes, by 2. If I take a rectangle and then if I place a hypotenuse, then it will be two equal triangle. Lower triangle, we are talking about 2x. So he is saying integral that can focus on area, not on the height into width. So everywhere we are focusing into height into width. One is height is 2, width is 5, done. One is height is fx and width is x, fx into x, done. But integral calculus is saying height into width. Don't concentrate into height into width. Concentrate on calculating the area of the graph. So area of the graph, if it's 2x, 2x, that at any moment the end, the height is 2, height is 2x, then height is 2x. If height is 2x and width is x, then area of the triangle is 2x square. If that is true, then area of the rectangle is 2x height. If there is a if there is a triangle fx equal to 2x, means x equal to 0, it is 0, but it is making a slant line. If this is x-axis, then this is the 2x. It is not perpendicular. It is like this. What is area? This area. This is nothing but if this it was a rectangle, then half of it. So if what is this height is? That is 2x. What is this width is? X. So rectangle is 2x into x, 2x square divided by 2x square. X square is the net collection, whereas through the algebra we directly multiplied fx into x, 2x into x, 2x square. But actual result is only x square. So if we are trying to calculate the net addition, net collection through only through area, it becomes integral calculus. If I have the area, if I want the function back, then this procedure is called differentiation or differentiation, derivation, derivative, because it is division. If 2 into 5 is 10, then 10 by 2 is 5 back. 10 by 5 is 2 back. If 2 is the function, 2 into 5 is 10, then 10 by 2, 10 by 5 is 2 back. So fx, so now how the representation is? If I see the numeric multiplication, it is 2 into 5. Algebraic multiplication fx into x, whereas integral representation is fx dx, not into fx dx. Like that, if it result into gx, then algebraic division is gx by x, whereas calculus differentiation is dgx by dx, because we are calculating the uh, rate of collection from collection. If this is rate of collection fx, then gx is collection. Rate of collection is gx by x. At every moment of x, the gx by x is different. So we say it dgx by dx. So if I calculate the derivative, please watch the previous video. So if I need to calculate the derivative, that is from gx to fx back, then it is dgx by dx, means if I have x-axis and this is the gx graph, then at any moment x, what is gx value, and at any moment x plus delta x, what is gx value? That is gx plus delta x minus gx divided by delta x tends to 0. This way we calculate through the first principle, we calculate the area, we calculate the differentiation. Through first principle, we had problem in calculating the derivation of sin x, because at sin gx plus delta x minus gx, or gx plus delta x minus gx minus delta x divided by 2 delta x, it resolved into cos x sin delta x by delta x. And we were not satisfied with this fundamental, that it will be sin delta x by delta x tends to 1 if delta x tends to 0. Then we went by polar coordinate system. So polar coordinate system, what we are seeing is, if this is a circle, if this is a circle and this is the kind of radius, okay, so consider this is the base. If it is moving, then from the base it is making, I should have tied it. Okay, I'll try. It really works, then it will be really nice. Okay, this is a circle. If this is a circle, then this is the base radius. This is the base. You can say this is x-axis and this is y-axis. Whereas this is a radius and radius is rotating and it is making theta angle. So if radius is rotating, or better. Okay, if this is if this is circle, if this is circle and this is radius, if this is radius, if this is circle and this is radius, then consider that this radius is moving. This is the base point. Radius starts moving. Radius is moving, and then it is at angle theta. If theta is growing, then theta will grow up till 2 pi. So if it is angle theta, then this is angle theta. This is angle theta. If this is angle theta, then this is perpendicular. This is point P. If I take any theta angle, if this is the polar coordinate, if this is the circle, if this is the circle and this is centered at the origin, then at any when I take a radius where theta is 0 and then this radius starts moving and it is at theta angle theta at this moment. So this point, that is origin, we call it O, and this point where theta angle is, it is touching the circumference, it is P. Now it is making d theta movement. This is P point angle theta. Now it is adding more angle, that is d theta. This is another point called Q. This is P and this is Q. P, Q, 2 points. Okay. Then if this is P, this is Q, then this is arc. This is arc. If this is P, this is Q, this is arc. This arc belongs to angle called d theta. This arc belongs to angle called theta. So if if this arc is theta, then this point is P. From here, I move again and we add delta theta. This arc belongs to angle delta theta. This is Q. Okay. So if now when this is theta, this point we called it P. Draw a vertical line here. If you draw a vertical line here, this forms a triangle and then line goes up. When I move it again, this is P, this is Q. Draw a horizontal line here. This is Q, this is P. They cut here. Then again they make a triangle. This an arc. This is the arc and this vertical line, this horizontal line. So it is something like we have shown it. So it is something like, okay. So this is typically a triangle. Concentrate here. This is a this is again a this is again a triangle where one angle is perpendicular 90 degree, where this is one angle and this is one angle. Other side of triangle is the arc. So this forms a triangle, where triangle, then where my this finger is, this is 90 degree, and this is one angle and this is one angle. This is arc. This is the another side of the triangle. So this arc, we are considering it as a straight line. Straight line means if this is the formation of the triangle, if this is the formation of the triangle, if this is the formation of the triangle, this point is P and this point is Q. From P to Q, angle is d theta. and this I am considering as a straight line, means P and Q is connected by a straight line. Straight line. And then it forms a full-fledged triangle where this arc length is, if radius is a, then a d theta. When d theta is very small, the line what it connects the point P and Q are connected by arc. Now P and Q are connected by a straight line. The length of the line is r a d theta. Considering d theta is very small, then arc would be of equal length to the line. This is the approximation we are taking. If that is the case, then I have a triangle. I have a triangle where this is 90 degree. What is this height? Okay, so let's begin again. Now, if I have a circle, and then we started moving the radius is at angle theta. If you see it clearly, then the height, this point, this height, is y, and this width is x. Y by x is tan theta if angle is theta, whereas hypotenuse is the radius itself, that is x square plus y square square root. So sine theta is y by square root of x square plus y square. Now if I am at angle theta, this is y and this is x, then sine theta is y by square root of x square plus y square. If that is the case, then now I move it by d theta. If I move it by d theta, earlier the point was here, then if it moved by d theta, then there is a height difference. Earlier the height was y, then next height is another. How much it moved is delta y. So it moved delta y. Now we have two triangles. One triangle is, if I move it by theta, then this is P point. From P point I draw a vertical line. P point, I draw a vertical line. If I draw a vertical line, it forms a triangle here. And that vertical line, now if I move it like this, from here I draw a horizontal line. And previous vertical line. And then this arc, this forms another triangle. Now let's see here. If this is the triangle, if there is a vertical line here, then this angle is 90 degree. This angle is theta, and this angle consider alpha. Now, if I draw a vertical line here, then there are three angles here. One angle is this, another angle is it makes with the arc. This is the arc, then it makes angle with the arc. Another angle is inside the another triangle. These three angles, if we add, it also 180 degree. If this angle is 180 degree, then this angle, and this angle with the straight line is also 180 degree. This angle, that is with the arc, it is making an angle that is 90 degree, because radius and arc, they are perpendicular to each other. That's why it is polar coordinate system. They are orthogonal. 90 degree, this degree, we call it alpha. Alpha plus 90 degree plus inner angle is 180 degree. Alpha plus this angle and the 90 degree is 180 degree. This proves that if this angle is theta, then in higher triangle this angle is also theta. The higher triangle is this, where this one is delta y. If higher triangle is this, then this one is delta y, and if this is delta y, then this angle is theta. This is 90 degree. This is another angle. If this angle is theta, then cos theta is delta y, that is base, by this hypotenuse, because we have connected this line. So this is a triangle. Look at here. This is a triangle. If this is a triangle, then this much. This one is delta y. If this is delta y, this angle is perpendicular. So this forms a triangle where we can have cos theta. This angle is theta. If this angle is theta, then base by hypotenuse is cos theta. So base is theta, base is delta y, where hypotenuse is the arc which has angle delta theta. So arc is a delta theta. So cos theta equal to delta y by a delta theta. Okay, if that is the case, then cos theta equal to a into dy by d theta. Now go back to earlier. If this is the beginning we had taken and this is what it is rotating when it is at angle, oops, when it is at angle theta, when it is at angle theta, then this is the y, this is point P, this is the y, and this is x. Then sine theta equal to y by hypotenuse. Hypotenuse is constant, that is radius a. So sine theta equal to y by a. D sine theta by d theta equal to d of y by a by d theta. Or if I take out a outside, then 1 by a dy by d theta. Now we calculated cos theta is nothing but dy by a dy by a d theta. So let's substitute dy by d theta to a cos theta. If we substitute, then d sin theta by d theta equal to cos theta. Straightforward. Now we have what we need to prove. I'm really sweating. So what we need to prove here, that the arc, what is the only thing that we are lacking here? We also approximated that arc, since arc belongs to an angle. If this is the if this is the if this is the radius, if this is the radius, oops, if this is the radius, if this is the radius, then, and this is the arc. Can you see, this is the arc? From here to here there is an arc. This arc belongs to angle theta. Every arc, portion of the arc, if I connect two end of the arc to the center, it belongs to an angle. That angle, okay, so when the arc belong to angle d theta, delta theta, we consider arc as a straight line and make it hypotenuse of the top triangle. So that is the approximation we did. Not only that, we also considered that a straight line is perpendicular to the radius. Okay, so in algebra, when we prove the differentiation of sine theta as cos theta through first principle, that is gx plus delta x minus gx minus delta x divided by 2 delta x. When we try to prove it through this, then we end up into x cos x into sine delta x by delta x. Then we thought that since delta x tends to 0, since sine 0 is 0, if delta x tends to 0, then sine delta x by delta x is 1. But that approximation I don't like, because if there is a slight mistake also in sine delta x and delta x value, certainly it will not be same. Delta x and sine delta x, even though delta x tends to 0, they will not be same. There will be slight difference. Then lot of change we can see in the result. So we went through this fundamental. So rather than going by delta x limit approximation, let's go by trigonometry algebraic way. Algebraic does not have any approximation. Algebra itself is dynamic. If you have algebraic function, keep changing the value of x and you will get different value. But our hypothesis is based upon that any moment on the curve, if I have radius, then radius intersect the arc at 90 degrees. How we can prove it? That is the question. If we prove it, then at any point, if this is angle theta, then at that moment, the arc we have taken, that arc is nothing but perpendicular. That moment, I'm not talking about delta x. The point at angle theta, the point where radius is touching the circumference, at that point, not delta x from there. At that point, the circumference arc, the circumference is perpendicular to the radius. At that moment, it is perpendicular to the radius. If it is perpendicular to the radius, then automatically that angle what we have taken as line, if you remember the higher triangle where it has three sides, one is delta y, one is delta x, we can call it delta x, and one is the arc. Arc, the main thing, arc has 2 points, one is P and one is Q. P and Q we connected through a line, saying that this line is of equal length to the arc, considering arc is very small, delta theta is very small. So when arc is a delta theta, the length of this line is also a delta theta. But that is not the main assumption. Main assumption is arc, that line what we have taken, that line must be perpendicular to the radius. That is required. If it is that line is perpendicular to the radius, then only that angle will be theta. In a higher triangle, if you remember the top triangle, there are two triangles we have taken. One is base triangle where we have to calculate the sine theta. One is the base triangle where we have to calculate the sine theta. This is theta. And then if you move from here delta theta, then 2 points came, Q and P. From P, if I draw a perpendicular line, from Q, if you draw a horizontal line, then it becomes something like this. Okay, so this length is delta y, this length is delta x, and this arc length belongs to delta theta. So length is a is radius, a delta theta. If that is the case, then what we did is, if there are 2 points P and Q, we draw a straight line P and Q, and considering this straight line same as the arc, because arc is very small. But that is not the main problem. Main problem is, if I make the higher triangle, this angle, higher triangle means it has three angles. One is perpendicular angle, one is this angle, and one is this angle. So this angle is theta. If we started with the theta as a lower angle, lower triangle angle, that angle is theta. That angle is theta only when this line what we have taken is 90 degree to the radius. So we have to prove now that radius and arc, where the point they touch each other, at that point arc is perpendicular to the radius. So that is the idea. So we will prove it. So now we will, at least we can begin it. A lot of time we have wasted. I would say wasted because we repeated many things. So idea was to start that vector form. But anyway, consider that what is the algebraic equation of this circle? That is x square plus y square equal to a square. The algebraic equation of a circle is x square plus y square equal to a square. Actually, the equation is a square y equal to, or fx equal to, square root of a square minus x square. So if this is x-axis, we will prove it in polar also. So this is Cartesian. If this is x-axis, then this is y-axis. If any point, if we have x, any point we have x, then what is the y? X, then what is the y? X is 0, then what is the y? Y is square root of a square minus x square. If x is 0, then y is a. If x is a, then y is 0. X-axis interception, y-axis interception. So if that is the case, then can we prove that the any moment, any point, the arc and radius are perpendicular to each other? If that is the case, now consider the kind of, if fx equal to square root of 1 minus x square, fx is equal to square root of 1 minus x square, then kind of what is its gradient vector? Gradient vector in the sense that a vector which represents its derivative. What is its gradient vector? So fx equal to square root of 1 minus x square. So if I calculate the kind of If I calculate, this is the, if this is algebraic, if this is algebraic equation, y equal to square root of 1 minus x square. First calculate the derivative. dy by dx, dy by dx. What is dy by dx? dy by dx is partial derivative along x-axis. If I have fxy, dfxy by dx or dz by dx, partial derivative along x-axis. dz by dy is partial derivative along y-axis. If I have fx, not fxy, fx, then dfxy by dx is partial derivative along x-axis. Though only we have x-axis only as independent component. So derivative of square root of a square minus x square would be minus x divided by a square root of a square minus x square. So minus x divided by square root of a square minus x square is the gradient vector. I have to place I because we are differentiating with x, partial derivative along x-axis. So the gradient vector has a direction. So gradient vector along x-axis is minus x divided by square root of a square minus x square I. I is a vector. You can write a small I on top of it. You can place arrow. So dfxy by dx is partial derivative along x-axis, that is minus x divided by square root of a square minus x square I. Let's put x equal to a. If x equal to a, then it becomes infinite. Means if I have a circle and if this is x-axis, this is point a comma 0. This point is 0 comma a, being this is radius a. So if this is the radius angle 0, this is 0 0 centered at origin, then this point is a comma 0. If that is the case, then at this point the gradient vector is infinite I, means completely in this direction. Okay, means there is no essence of y vector. If y vector is there, then it has no. If gradient vector is like this, if radius is the gradient vector, if radius is the, now we can say that the radius is the gradient vector. Okay, I, if I see I axis means that is the radius at angle 0. If I see x axis is nothing but the radius direction. Radius direction is what we get as infinite at a comma 0. What about the partial derivative when x is 0 in vertical direction? So x is 0, then it is 0. So at this point, if this is the x-axis, this is y-axis, then at this point, this gradient vector had no essence in along x-axis. Okay, this much we can see. What we have calculated now, that if I have a kind of a circle, then if I calculate partial derivative, then partial derivative along x-axis we have calculated as if the equation of circle is square root of fx is equal to square root of a square minus x square, then partial derivative along x-axis is minus x by square root of a square minus x square I. So when x is a, then this is full-fledged a kind of only infinite I. Now I have to prove this, that the point, if I take point a comma 0, if I take point a comma 0, point at a comma 0, okay, point at a comma 0, I cannot prove it. Now we have equation the line equation, curve equation as square root of a square minus x square. It does not have any direction. But once we calculated the gradient vector, then it has direction, that is minus x divided by square root of a square minus x square. And when x equal to a, then it is infinite I, means it is completely going into the x direction. We will proceed proceed on this, and idea is that we have to prove that on the circular arc, any point if I take, then radius and at that moment the arc are perpendicular to each other. If that is the case, perpendicular to each other, then if I take a line on the arc, if I denote the arc as a line, then line will be also perpendicular to the radius. Then it solves our sine theta, and will proceed in the vector direction also. So that we will see.